In your lesson today, Lesson 9.1, Quadratic Graphs and Their Properties, the key thing that we are going to be taking a look at is how do you graph a quadratic of the form y equals ax squared and ax squared plus c. So we looked at your graphing calculator activity on Wednesday. You can keep that until I return on Friday instead of handing that in. Key thing to understand is you look at your notes, an example of a quadratic function. So when we look at an example of a quadratic function is going to look like one of these two. It could also look like this one here. So a quadratic function is where we have y is equal to ax squared. It could be plus a bx plus c, or it could be just y equals ax squared, or like the last case that I was just showing you, you could have an equation where you have something like y equals ax squared, and it might be plus c. So those are going to be the three main cases. A quadratic function of the type is a nonlinear function, and it has certain models. So the situation where a rate of change is not constant. Remember, linear is where our rate of change is constant. So when we look at our equations in a quadratic function, it is written in this form, ax squared plus bx plus c. The variables are a, b, and c. Those are our, and if you look at that, it says where a cannot be 0, because or else it would be linear. So here are some examples of ones, and the characteristics that we are going to be looking at. Now, the characteristics that we are going to look at is that, as you turn to the next page, and you will see of your notes, is that this quadratic equation is going to be the shape of a parabola. It's really a U-shaped curve. So every time we graph it, we're going to be looking at a U shape. It is also symmetric, so it has an axis of symmetry. You can fold a parabola so that the two sides match exactly. This is called symmetry. That fold line, notice that would be in this case, this line. What is the equation for our particular axis for the axis of symmetry? In this one, if we look at this line going right down here, right on top of the y-axis, the equation for that would be x equals 0. Now remember, this is a slope that's undefined, and all of our axes of symmetry are always going to be x equals a number, because the axis of symmetry is always going to be a vertical line. So when we're talking about that, we always want to have a vertical line. That is our axis of symmetry. So when we talk about our quadratics, we're going to have some special points, the highest and lowest. And these are points on our parabola, and it's the points that are on our vertex. So this point right here is called the vertex of our parabola. So when we are thinking about this, if A happens to be greater than 0, then the parabola is going to open up. Okay? An example of this is down here. So our parabola opens up, and if we were sketching it, you might have some points like this, and what's going to happen is that they're going to be symmetric exactly on the other side. And so you can see from my drawing, it's not perfect, but as we're drawing these on a graph, it would look like this. This is our minimum point. Okay? When A happens to be less than 0, so A is a negative number, then our parabola is going to open down. And when it opens down, you then have a maximum. So now you might have something that looks like this. Now mine obviously is not symmetric, but yours will end up being symmetric. And our maximum is this point right here as we are looking at that. Can a parabola have both a maximum, and if you look at your notes, and a minimum at the same time? No, it cannot. It must either be a minimum or a maximum. So you're going to be asked in your homework, what is the vertex of the graph? Well, the vertex in this point would be at 0 and up 3, 0, 3. Is it a minimum or is it a maximum? This would be a max. All the points are below this. So this is our maximum point. In this graph, if we are looking at the vertex, it looks like our vertex is pretty much right here. We would say that's at 1, negative 1. So our vertex is at 1, negative 1. And this would be a minimum. Now, if I asked you, as you were looking at these, what is your axis of symmetry? If we were looking at the axis of symmetry, And if we're looking at the line for the axis of symmetry, in this case, we would be looking at x equals, it's right on top of this. What is x everywhere? 0. In this line, if we were looking at our axis of symmetry, our line here for axis of symmetry would be that x is equal to 1. The vertex is always on the axis of symmetry. So that's always kind of a nice thing, kind of cool as we're looking at that. So we can use these facts about a parabola, and it's always going to be symmetric. So the first assignment today that I'm going to be giving you, I give you all the points to pick. But if we are looking for this, one of the first things we want to try and do is find the quartets of our vertex. It's always an xy point. Then find 2 points on either side, 2 greater, 2 lesser values. We want to reflect it and connect the 5 points. The key thing I'm going to have you do is as we make our XY charts, most of ours as we start graphing, we don't have to find our vertex first, is we are going to be going from like -2, -1, 0, 1, and 2. So when you do the worksheet on Thursday, you're going to be asked to come up with these points as you are looking at that. All right, so when we look at graphs that are of this form, y equals ax squared, where is our vertex going to be located? If we are looking at these, always our vertex is going to be located at 0, 0. Why? Because every time we replace x with 0, we get y is 0. The axis of symmetry, like I spoke before, is always the x coordinate of our vertex, so x equals 0. It is the x coordinate, if we are looking at that, of our vertex. That's how we get that line, okay? So the axis of symmetry is at x equals 0. It is always that vertical line. The equation for the axis of symmetry is x equals 0. As we take a look at graphing, what if you're asked to graph something like this and I don't give you values? It says graph the function, make a table of values, what is the domain and range? Now, one of the things you notice is that you have 1/3. So you may want to pick some kind of special numbers for your x values, but I think as we do this one, we're going to get some fractional answers, but so that it'll fit on our graph a little nicer, we're going to go from -4. I am going to do -3. I'm going to show you what -1 looks like. 0, 1, 3, and 4. Now again, we know that when we put in 0, 1/3 times 0 squared is going to be equal to 0. So the ordered pair, our vertex, is going to be at 0, 0. I now want to take a look if we're replacing the other values. Now, as you do each one of these, remember order of operations. You have to square the -4 first. So if we're squaring -4, that's going to be 1/3 times 16. So at -4, we're looking at 16/3, or if you wanted to put 5 1/3. So at -4, we're going to go to 5 and 1/3. So just right there. If we plug in -3, we're going to have 1/3. We're going to square -3. Remember, you got to use your when you use your calculator to put it in parentheses. So that's going to be 1/3 times 9. So when we put in -3, we should get out +3. So at -3, we are going to be at the point +3. When we put in -1, we're going to have 1/3 times -1 squared equals 1/3 times 1. So at -1, we should be at 1/3. So at -1, we're really close here. So what does our parabola look like? Well, remember, it's going to be symmetric. So when you replace 1, 1 is going to be at 1/3. What's going to happen when we replace the 3? Well, 3 is going to be the exact same as when you replace it with -3. So it comes out to be 3. That's not negative. That's 3, 3. And then when you replace it with 4, you're going to get 16/3 again. So it's going to be exactly symmetric. Following this, sometimes you know how my tablet doesn't work. So if we are graphing this, it's going to not let me move right now. Is it not connecting? So yours is going to be a parabola. All right, so it disconnected for a minute, so now I can graph this. When we're asked about our domain, going back to earlier this year, as we think about the domain, that's all the x values. If we are thinking about what is our domain, we should have all real numbers. Every value of x can be put in. What is our range? Well, notice our graph goes everything above 0. So we're going to say it is all real numbers where y is greater or equal to 0. Where is our axis of symmetry? Well, we've just seen that our vertex is at 0, 0, so x equals 0. Remembering that that axis of symmetry is really this vertical line that's right on top of that. Now, one of the other things you're going to be looking at is what happens to our different quadratic, what makes it wider or not. This is kind of from our graphing calculator activity. This is not in your notes. So think about what makes it wider or narrower. We're going to look at those from our graphing calculator activity. When you're asked to do the assignment in the book, you kind of are going to be looking at wider or narrower graphs. And again, you can use the graphing calculator. And if we think about what does the sine of the A do to our parabola width, it really doesn't do anything, the sine. What does the sine affect? The sine affects if it's positive, our graph is a parabola going up, and if it is negative, our graph goes down. But the sine does not affect the width. So right now, you're going to be looking at your homework tonight, which looks like this. You are going to fill in the values. Please make sure you remember in square first before you multiply, so using order of operations. Here you're going to square, then subtract. So you have this page and you have the next page that you will be doing tonight. This is on your first blue worksheet. When you come into class on Thursday, you guys are going to be looking at having that worksheet done, but as you look at this worksheet that you'll get on Thursday, you're going to be looking at putting in your x and y values, and when we do this, what I'm really looking for is that you make a table of values, and when you make this table of values, I always want you to have from -2, -1, 0, 1, and 2. And on this worksheet, which is green, you are only going to do 1 through 9. Do not cross off the rest because those are going to be coming up later. It's just that we're not going to get to these more complicated ones. We need to be able to find the vertex first, and that will come in our next couple of units that we're doing. Hopefully this was helpful. If you need to go back and replay it, it is attached to the daily planner, and you should be able to do that. Thank you.